we've been talking about the AI mission for the longest time. What does it mean in theory? What does it mean in practice?
The fundamental of your option pricing theory is based on physics.
But in the next 2 years, you're going to see somebody going to show quantum advantage. And it has to be out of India.
This is a revolutionary state of matter achieved for the first time, as Microsoft is claiming.
There's no pressure, guys. We just need to basically look at maybe 70 to 80 years of research on quantum mechanics and put up a good session, a good show for 60 minutes. But a pleasure to have you all over here at what I think is an iconic event. It's great to have you guys in the audience as well. I know the moniker, the title of the session is Quantum Computing, the Jet Fuel to Power AI's Growth. But I'm going to take the liberty of correcting that. It is the jet fuel to supercharge everything as we know it. Professor Rapol, I'm going to start off with you. Am I correct in renaming the session on the spot? We can.
Okay, I think you're right. You can rename what you said just now. But I guess we need to probably give some background on what this quantum computing is all about and then how it's going to supercharge.
So let's break it down. Let's break it down, Professor, because while everyone's been talking about artificial intelligence, that's become the buzzword, right? How many of you, quick show of hands in the audience, have used some sort of AI tool in the past 2 years? Okay. That's a good 90% of the audience. And the concern I have, Professor Rapol, is Web3 came and it was the cool buzzword for us for the longest time in the content world, in the tech world. Now it's AI. But if we are talking about the future, and actually the future is now, shouldn't it and wouldn't it be quantum computing? Could you explain to us the significance of the subject that we're discussing?
Yeah, I think we need to shift gears back to the last century. I think what we are actually into this century is into quantum revolution 2. The first quantum revolution happened in the beginning of last century, where quantum mechanics was invented and many counterintuitive principles, they were it came into existence and it became a complex topic in the beginning. But then, however, quantum mechanics, the basic principles of quantum mechanics, which are very complicated to understand because everything is counterintuitive. For example, it's even hard to imagine simple things like wave-particle duality, which means particles and waves, like they interchange their character. There are things like quantum tunneling, for example, where you throw a ball at the wall and then there is a probability of finding the ball on the other side of the wall. So things like this, strange things happen at the scale of atoms and molecules and electrons and so on. Now, these principles were utilized to design certain materials and devices and systems over the last century, and that the result is that we have what you call the CPUs for our computers, the mobile phones, everything work on these principles. Now what we are entering into is the second quantum revolution, which essentially is that you are now trying to engineer these quantum mechanical principles in such a manner that you are going to beat the limits posed by all the classical technologies, be it computing, be it any kind of sensors, be it light sources, be it sending information very securely. All these are based upon engineering these concepts of quantum mechanics. Now, for example, one of the things is that there's a lot of buzz going on development of quantum computers, and there are many serious efforts that are being put into across the world, including in India itself. Now, these, the quantum computers themselves is a part of all this quantum technologies area, okay? Now, these quantum computers, they have a potential to solve certain problems way faster than any classical computer can do. When I say a classical computer, I'm talking about huge supercomputers,
right?
For example. And things like designing drug molecules, for example, which might take, I don't know, many months, for example, to design a set of these molecules. You could probably design them much faster in a day or two, for example, whenever we have the working quantum computer, which can solve real life problems. Yeah.
So there's a bunch of use cases in medicine, in drug discovery, supply chain, agriculture. The list is endless. The kind of compute time, ability, things will change. But that's the promise of the technology. I wanted to paint an image of what this technology is capable of. Venkat, but I believe, and I think every expert gives you a very unique take. Venkat, I think the one thing that will stay with me from Convergence is my conversation with you and you telling me that quantum, AI, they all have a feline problem. And when I say feline, I literally mean a cat.
So, all of you, when you were kids, how many cats did you have to see before a new cat came and you said cat? Maybe one, maybe two, maximum. So, we humans are very good at processing data and inferring from it. Do you know how many cats the AI systems of today need to see? Thousands of cats. Cat from this angle, cat from this angle, cat, occluded cat, kali billi, white billi, all sorts of billies before the AI system knows that this is a cat. So that's a cat problem and it's a big problem. Why? Because we all know LLMs, we all use ChatGPT. Every time a new LLM comes up, because of this cat problem, on this side LLM, on this side power station. Because of that inefficiency of this cat problem. Instead of using one cat to infer that this is a cat, you're now seeing 10,000 cats to learn that this is a cat. So that inefficiency is because of bits, zeros and ones. Everything you do on the best supercomputer today is zeros and ones. And you are representing cats, which is a three-dimensional object and which your brain is able to process so efficiently. You are you are inferring that using the zeros and ones, the bits, which is what today's computers use. And as Dr. Umakant, Rapol said, the quantum computer brings new paradigm of computing. Today, computing has branched. There are two types of computers. One is your bits, your mobile phone, your laptop, your supercomputer. And on the other side, you now have a new kind of computer which uses what are called qubits. And that qubit is enabling people to infer that same cat more efficiently. So that you don't need 10,000 cats before you can say that's a cat. More towards the human ability of seeing a cat and inferring that this is a cat.
You know, and building on the cat example, there's also experts, and we can build on it. When he was talking about bits, and as a student of technology, we always think of ones and zeros, and we think computers, tech is so logical, but the real world is different. Matters of the universe are different, elements, atoms, molecules. There are tech companies, some on this stage and some not on this stage, who are building revolutionary tech when it comes to how we interpret science. But there's also explanations with cats, by the way, Venkat, which involve Schrodinger's cat, because when you put that cat in a box, how do you know if it's dead or alive? That's just two combinations. But what if it's skiing? What if it is eating a nice hamburger? These are questions in a layman's terms that quantum computing can solve, right? Now, Sachin, if we want to build on what companies are doing in this space, I know AWS, IBM, and of course, Microsoft and Google are some of the big tech names that we associate with quantum computing. In some cases, with AI and LLMs and data centers, the companies that didn't invest early on seem to have missed the bus. And that's at least the narrative about a lot of tech companies. In quantum computing, do you think some of the top tech companies are doing enough? And what's the story here in India?
Can you hear me? Yeah. See, whenever a new tech comes, you gave the example of LLM AI. See, it came from some of the large companies only, but then it was massively adopted by people. The technologies can be developed in research segment by the scientists, but eventually the small startups, the enterprises, they bring that to life, to our life basically in day-to-day use. Same is true with quantum actually. Right now quantum, as we say, like in early stage of development not yet there for us to use in day-to-day terms, but no one has been left behind here actually. When we talk about different use cases, see, Professor Umakant and Venkata explained that what quantum is doing, but see what immediate use cases could be. Some of the use cases, like if you define quantum, you will see problem statements coming in two categories precisely. Either they are optimization problems or simulation problems. There may be more, but I'm just trying to bring them in under two buckets. So you're talking about your finance portfolio optimization that we will do as individuals or enterprises. Maybe we will talk about some kind of traffic optimization. So these kind of business problems, quantum can help solve. Now, if these quantum computers are coming in place, who will build the applications? Eventually, these application organizations and the same talent pool that we have, they will get one more tool in their hand to solve these complex problems. So no one is left behind actually. It's just like one more tool coming up, making our life easier, exactly the way LLMs have done.
So, sir, let's build on that, because when we talk about the talent pool, I think so much can be said. There's so many things happening geopolitically. If you consider what's happening in the US, there was talk of brain drain during the IT revolution. With AI now, we've already seen, to some extent, reverse brain drain. With the startup revolution here, the unicorns coming up in India, a lot of young minds are coming back. Some even dropping out of Ivy League universities to come back. When we talk of quantum, we're not talking about just today. We're talking about probably the next century of innovation and development. So, sir, tell me, from some of your professional and policy leanings and experience and expertise, how prepared are we in India to really be spearheading the quantum revolution, whether it's with AI, whether it's with blockchain, but how prepared are we to retain that talent and, with our existing talent and workforce over here, upskilling them with the right sort of programs?
So, talent is the biggest challenge, and it's across the world, across the board, first of all. As far as India is concerned, as a country, we are looking at something called as National Quantum Mission, which is actually being very closely monitored by the PM himself. So we need to understand the value proposition coming from the topmost authority in India. First point. Second, right now, National Quantum Mission has launched an 18-credit minor BTech program. And Venkata and myself, we sit on a committee where we are formulating MTech course for engineers and scientists and mathematicians and physicists. That's the effort that the government is putting. Now, there's a lot of effort that we as individuals also have to put. Now, I was talking to you during the initial conversations. So please understand, all of us sitting out here in next 10, 12 years will be in a different league of life. Let's start looking at the school children. Yep. They are the consumers of whatever we are talking and whatever we will be producing in next 10 years. How do we train that talent? How do we train our school children, 7th, 8th, 9th grade students, make them understand fundamentals, not very complicated, in their language? That has to be done. That is an effort that the society has to take. So there is going to be a two-way game. One is obviously what the government is doing, no denying, a lot of effort is going into the game, and about 100 odd colleges and universities, they have already been part of the BTech minor grade. So I am also helping IIIT Ailawadi to help them set up their MTech in quantum computing course. And we are working in that area. So masters is definitely important. Bachelor's is already happening. What about the school level? We shouldn't miss this bus as a nation. We shouldn't miss this bus of teaching our children. That's one aspect. Youngsters, everybody good. But we also need to learn. I mean, both from the industry perspective, at least get the key words understanding. And as well as from the policymakers. So when I say policymakers, I don't only mean the bureaucracy, but also the other wings of the government, the military establishment. Because you see, the game of quantum computing will be impacting the military at the fastest level. Okay. It is going to be the one that is going to be hit the at the high speed. So we need to train and teach and reteach all of ourselves.
That's very interesting. Professor, he just mentioned the quantum mission. And we've been talking about the AI mission for the longest time. What does it mean in theory? What does it mean in practice? The genesis of our discussion today is quantum computing, the jet fuel powering, AI's growth and India's growth, so to speak. If we want to achieve global leadership in this space here in India, maybe in 2047 or 2050, because it's a long-term game like you've discussed with me before, how much of synergy is there in the quantum mission and the AI mission? There are documents right now, but you all are working behind the scenes on how much synergy and consonance is there between the two missions? Because honestly, they have to work in tandem is what I understand.
Right. So one of the things that certainly is there in the quantum mission is on developing quantum algorithms. So quantum algorithms is something which can go independent of hardware development, because at some level, for some of the algorithms, you really don't need a quantum computer. You are using the principles of quantum mechanics to solve certain problems in a quantum mechanical way on a classical computer. Now, in those aspects, at the moment it is, I think globally also, it's not completely clear as to where exactly these quantum algorithms can actually, which particular problems within the domain of AI can quantum mechanics solve. But there are a lot of efforts going on, and
right.
I think this is the right time to actually start getting these two together, because as you said, by 2047 or 50, this thing has to completely develop into a very mature
Exactly. So
technology,
this is the right time, the right hall, the right place, the 32nd edition of Convergence India Expo. I'm glad you all could be here. I'm glad I could be here. But Ashwin, you're very far away from me, but you're in my thoughts. All right. We're in the same atmosphere, in the same hall. Ashwin, from the work that you're doing at your company, at your startup, it's fascinating because you've been at the intersection of blockchain, of AI, and now quantum as well. You're building solutions and you understand cybersecurity. Honestly, I can hand over this panel to you now and you can tell us a little bit from a bird's eye view. But tell me, what are the challenges that we face? And can I just put a little, set a cat amongst the pigeons, the way Venkat, I'm building on your analogy there, set a cat amongst the pigeons. When we talk of IBM and obviously and AWS and Google, Microsoft, and this is a quantum race, let's be clear about it. Microsoft, for context and for the uninitiated, a few days ago, a few weeks ago, came up with something which seemed to, at least from their marketing, completely revolutionize quantum computing. I think everyone in the US and in the tech world was completely blown away by what it was, but there were questions. They speak of, and obviously Ashwin will explain this better, Majorana. This completely changes how you look at some of the qubits they were talking about, the atoms, the particles. They've claimed to have done something that was never done before. Now, this is a claim in theory, but in practice, what does it mean? More importantly, Ashwin, if we're talking about this sort of rapid development and advancements, then maybe we are wrong on this panel to think that we'll see breakthrough innovations coming in 2050. It could be today, it could be tomorrow, couldn't it?
So you're absolutely right. Revolution can happen anytime, but just like Microsoft was working secretly on this Majorana 1 qubit, whatever they're calling it. It's basically a topological state of matter with a spin 3 by 2. I think it has a spin. So so I'll not go into what the detail of what spin means in this context, because for that I'll need to take you to fundamental physics. But this is a revolutionary state of matter achieved for the first time, as Microsoft is claiming, although we are not certainly sure because there's still some evidence that needs to come in terms of whether this has been achieved and has been tested through third party and through researchers working in this field. But when you're talking about revolution in terms of emerging technologies, yes, you talked about AI, we talked about blockchain, and IoT or quantum. The idea is that all of them are coming up together, where we can see that AI is already leading the race. We are practically using AI in our phones, in our day-to-day life for whatever reason. Uh, so to answer your question, there could be two contexts. One is from the context which is the national context. We as a nation, how are we progressing in terms of these technologies? And as a global, being a global, race, where we stand and where the world is moving right now. So we all know, even in terms of AI, currently OpenAI or China has DeepSeek, and all of these technologies are pretty much in the forefront. India also is working on its own LLM, but we are not yet come up with a fundamental LLM which is competing with these giants as of now. Similar is the case with quantum technologies. Like in terms of hardware capabilities, these companies like IBM, let's say INQ or Pascal, and so many other hardware-based companies, they are pretty much ahead in the race compared to where we stand as a nation on the hardware front. And the revolution in quantum, to be precise, purely quantum would come from the hardware aspect, because unless the hardware works, the software can work regardless of the hardware, right? Like you can simulate these quantum-inspired algorithms on classical machines, or you can run quantum machine learning algorithms on your classical machines. The idea is that if you are using a quantum hardware, you should have an advantage, right? So where does that advantage lie? It lies when you have massive computing power on the quantum side, which is error-free, right? So most of the computing that is happening on the quantum side is prone to errors. And the advantage on the companies which are working on the software side could be that yes, they can work on these algorithms which can in future work on practical quantum computers and can be ready for that. But I'm going in a few directions, but the idea is that even if you don't have access to a scalable quantum computer right now, which is error-free, you can run these simulations on a classical computer and try to prove that with whatever scale of quantum computers that we have right now, which are called NISQ computers, noisy intermediate scale quantum computers, which are prone to errors, that we can show some quantum computational advantage in a hybrid setup where we are using classical as well as quantum. So that is one area where India, we are a software, we are ahead in race in terms of software development at least. So we should at least own up to that skill till the time we do end up building something on the hardware side, that we can revolutionize something on the software side. Obviously, I'm not saying that we're not working on the hardware. Whether it is quantum communication or computing, we have companies, we have initiatives from the government, and we have the National Quantum Mission, which is focusing on all these 4 pillars of quantum technology. But it will take time, although I'm not saying globally we don't have advantage. Like we have advantage globally, where people are using things like quantum sensors, which are showing that, okay, without using classical computing, you can show some quantum advantage, right? So it's like a complete landscape, right, of technologies emerging, where quantum is playing a very major role, and I'll just leave it at that, right?
Okay.
Yeah.
No, there's a lot more to build upon that. But Venkat, should we talk about cats or should we move on from that? No, I'm just kidding. Just to build on what Ashwin was saying, if we talk about quantum and the revolution that we are talking about, and some of the emerging tech trends that he mentioned, how do we ensure, Venkat, that there is a homegrown solution and that India genuinely becomes a hub of quantum computing, be it hardware, be it software, or the other technologies that will really augment this revolution?
Yeah, so I want to, very clearly here, set the context in terms of the timeline, because that's very important. So what was NVIDIA before OpenAI? It was a normal tech company. After OpenAI came out, what was NVIDIA? The most valuable company in the world. 900% it rose. Same hardware, same everything, But there was a change. What was that change? The change was the use case. Okay. Today, quantum, the hardware has already reached a point where you can run algorithms. 156 qubits from IBM. IBM is saying, in the next 2 years, you are going to see quantum advantage. What is quantum advantage? You take one application, you run it on classical, you run it on quantum. If the quantum one outperforms the classical one, and it's a real use case. It is not random sampling or anything that was shown earlier. It has to be a real business use case, whether it is molecular simulation, whether it is finance, whether it is optimization. It has to be a real use case of business value to somebody, and you need to show it on today's computers, the 156 qubits. Who's going to show that in the next 2 years? The question is very important. Who's going to show that? Because where is the talent today? It's in India. The talent is sitting in India. And if the quantum advantage does not come out of India, it's a big shame for all of us. So we better enable the young people who are already sitting. Of course, we need to start schools and colleges and everything. But there are 200,000, 2 lakh plus Indian kids who are already the best in the world. The best. We offered an NPTEL program, online program with IIT Madras. 15,000 students registered. 7,500 of these students were 12th class kids. Nobody told them, it's not there in their syllabus. There is no CBSE, ICSE. Nobody has quantum in their syllabus. But these kids went and learned it on their own because they want to be the best. And that combination of programming plus mathematics, you don't find it anywhere. So, okay, we need to do well on hardware. National Quantum Mission is doing it. But in the next 2 years, you're going to see somebody going to show quantum advantage. And it has to be out of India. We can take examples from the past, like PCs. PCs were everywhere. 1970s they came, but a startup called Microsoft brought it to our desks. Before that, PCs, you didn't care about a PC before that. Internet, 83, it was there. When did you buy internet? Only after Google and Netscape showed you that I can go to websites, I can search. Can you imagine a world without a browser now? How will you go to a website? These software were the thing that brought internet to our desktops. Before that, we were just happy playing games on our computer without worrying about the internet because it didn't matter. Same with AI. Before OpenAI, NVIDIA, normal company, 900% after OpenAI. Okay. Same thing with quantum. The application is important and the talent is sitting here in India. And we need to ensure that that talent is enabled through National Quantum Mission, through our industries, through our startups like Ashwin. We need to enable these people to make the next Microsoft or the next Google or whatever it is. It has to come out of here because the talent is here, the algorithms know-how is here, the maths is here, the programming is here.
I wouldn't want to really make that a bittersweet experience, but I want to play devil's advocate over there. And some of the things that you touched upon as well. The talent is here. Obviously, Venkat spoke about NVIDIA, and I had the good fortune of meeting Jensen Huang a couple of months ago. And I asked him the simple question, that with the IT revolution, and especially with what happened with call centers in India, we became a back office for the world's .com boom, to some extent. In AI, that was the concern, and we haven't seen so much of it happening, especially with the DeepSeek advantage now. We've really seen that our efforts are not as consolidated, as cogent as we wanted them to be. But my concern is over here with quantum now. These conversations are happening here at Convergence India Expo, and I'm glad we're having these conversations, but are we already a couple of steps behind in this particular instance? More importantly, all the talent that he's talking about, Why are they all applying for H-1Bs and whatnot and heading to the US? What is stopping us from building that ecosystem and infrastructure here?
Okay, so let me first nullify that point of view
Yes.
that, we are like lacking in terms of talent. No, we are not. Let me be very frank with you. There is a reason behind it, and that's what we were talking during the break, See, we are in, Venkat touched upon the point that we have got the best of talent as far as mathematics and programming is concerned. But has anybody had a view or a thought point, why is it so? Why is it that Indians are invariably good with mathematics and with numbers? We were the ones who built the number theory system, right? We were the ones who gave the world the zero. But why? There has to be a logical reason behind it. And the logical reason is not in science and mathematics, but in our literature, in our languages. See, when we speak, our languages are very scientific. Pa, pa, ba, ba, ma. I'm speaking through my lips. My tongue is not touching the upper part or the lower part of my jaw. Ka, kha, ga, gha, anga. The voice is coming from my throat. That's the science. Please understand. Let us understand one very simple thing. I'll highlight two aspects. One, we have a very, very large pool of BSc, MSc, mathematics, physics students. What are they doing? Searching for another call center job, searching for this job, searching for that job. We can train them properly because they have the inherent, or they have been, whatever ways you want to put it up in very mild terms, quantum mechanics is a part of MSc physics students. And it is one of the compulsory papers for an MSc mathematics students or BSc mathematics students. So we are already doing it. So there's no two thoughts about it. On the second point, and there's another point to it, in today's world, we are not getting a good physicist. Why are we not getting one? All of them are being sucked up by the banks. So the banks are doing something. Why? Let us try and imagine that. The fundamental of your option pricing theory is based on physics. So anybody who's read BSM, Black-Scholes-Merton's original papers would have understood it only if he or she has understood some fundamentals of mathematics and physics. So we inherently have it. We have the capacity and we have everything. So let me put it this way. I'll take back a step, about 7,000 odd years. I'll take one step back, and in Ramayana we come across that Hanumanji has to be told about his internal capabilities to make the Sena go across Lanka. It is like that with us. We are the Hanumanjis of the world. We just have to inherently bring out our capabilities, which we have it inside us.
Very interesting analogies, Sachin. So when we look at companies like AWS, IBM, especially here in India, what are they really doing to ensure that top talent comes through, is excited about the prospects of something like quantum computing? AI is already the buzzword. And are there things that you're doing in particular to work with the government, or even, like he was mentioning earlier, with schools for curriculum and stuff like that? Is AWS doing things in particular?
See, for any tech like quantum, see, it's not just enabling. One part certainly is that you have to enable the students, but it's all about creating the entire ecosystem as well. Right. Certainly, students have to be taught, because eventually what Atul said, that they'll be consuming, or rather they'll be building, but please understand the new startups that are coming up, they need to be funded as well. Existing engineers, we have large number of startups. When you say there are, which actually are coming up with the courses on AI, but how many of those startups actually are coming up with the courses on quantum? The existing workforce retraining. And the challenge, so now we need to understand what are the challenges and then accordingly create the ecosystem. That is where we precisely are focusing on right now. I'll take one by one. So the curriculum in the colleges that we are working on, we are trying to introduce the curriculum at the early stage, not at MTech, but at the graduation stage. Not yet at the K2, K12 stage, but multiple universities have started working on, or rather some of them have already introduced. But if I say that, okay, 10 universities have done that, that is nothing actually. We need hundreds or maybe thousands of that. So that ecosystem we are working on. Then post that, when this workforce comes into industry, they need to upgrade to the new tech. So these new courses have to be built up. The challenge current startups are doing is that if they need to launch a new course on, say, quantum or say on AI, they have large number of people, well-defined processes that how to curate the content, what to teach. That supply we have to fill in, that we have to bring in all experts together who can create those courses, starting from the 101 to the advanced courses. So that ecosystem we are also working on. Because we see, while research is working on bringing this quantum landscape in 2 to 3 years in real world, by that time, this workforce or this user base should also be trained on. The next level of challenge that comes is that, okay, even if a startup decides that, okay, we are working on one or the other solution, they do not get the funding because the investor ecosystem does not understand this. Rather, one part is that they do not understand these concepts. Second, from the investor ecosystem standpoint, their idea is that, okay, if I'm investing my money now, when will I get my exit? So that mindset that, okay, you have to invest for the 10-year, 15-year time frame, that has to be brought up. So we are working on that ecosystem as well. So it is about creating the entire ecosystem, plus then coming up with the application stack. We know that the solution will come into place when the entire stack is there. Entire stack, as we say, is hardware is there. I mean, NQM is also promoting that, build the algorithms, but there will be startups who will be building applications based on that. So if a new computer is coming, a new quantum computer is coming up, there will be certainly new tool chain, new stack, but then there should be new applications on top of that. So we have also set up a quantum computing applications lab where we give access to quantum computers where through the cloud service. Eventually, see, right now, if we talk about the computers or our servers or laptops, we can have everywhere, in our office, in our data centers everywhere. But how will quantum computers be accessible? So through cloud, we are also trying to give access so that people can build real-world application. And build, as we say, means they will be experimenting for now. We don't say that today the application will be ready for the production, but if 2 years from now that application has to be ready, they have to start now. So that entire ecosystem we are trying to cover.
Venkat, I want to come to that because we were talking about funding in this space. How are VCs and PEs looking at this? And you were at a conference recently, but what I found striking about that is that the millions of dollars that are being pumped in, even into the Indian startup ecosystem, and we'll come to Ashwin in a bit to understand what's the real picture. You have to say quantum plus AI to really capture the imagination of a lot of these investors. When will it become just quantum? You know, and we don't need to use the AI buzzword really to pique the interest of the guys funding these big startups.
Yeah, I think that's a very important point you brought up, right? Because, for example, Zapata became Zapata AI. Okay, so there are these startups which are learning that, oh, I need to do also quantum on the side to be able to survive. Okay, but there are some very interesting things also happening. Okay, the National Quantum Mission in October 2024 came out with a call for proposals from startups. They said, we will give you between 1 crore to 25 crores funding. And we all thought there are maybe 15 startups in India, 20 startups. You know how many applications came? 104. 104 startups came up saying, we want funding. And NQM in the first round selected 8 of them. Okay, so 8 of these were selected and funded. Now what is happening is those 8 startups are being pursued by VCs saying, take my money. So there is a joke in the Silicon Valley that, you know, if you have a quantum proposal, okay, in your car, you leave it on the dashboard and then go away for a few minutes. And a VC is passing by, he sees that proposal, he's going to break the glass and leave some money for you. That go, start the startup, okay. So that is something which we are now seeing, you know, the NQM by funding those 8 actually started a sort of an avalanche where now VCs are saying, oh, okay, the NQM has taken part of the risk for us. So the remaining risk, I can do it. I'm putting in. But also, before that, there are at least 5-6 startups in India which are decently funded right now. Millions of dollars, okay? So decent funding is there. But that appetite needs to go up. It needs to go up because many of the US startups or Canadian or Australian startups have received close to $1 billion in funding, you know, just 1 or 2 startups themselves. So we haven't reached that level. But also remember, Indians are very frugal. Do you know why all the CEOs in US are Indians? Because of, you know, taking less resources and giving big results out of that. And that's something Indian startups are good at. They've been showing it along the way. ISRO shows us the way. All the Indian, you know, startups, we don't waste money. I mean, there is Ashwin. I'm sure he doesn't waste even 1 paisa. He makes sure it comes
So
out.
frugal innovation is the way forward. I know there's an Ivy League scientist and a professor who's tried to coin it jugaad as frugal innovation. I don't know if you get the right flavor of that. Also, with your San Francisco example, I hope in the Bay Area, the break-ins happening, if at all, for that funding are under $999 because, you know, there's not going to be any liability there. But Professor Rapol, I want to get you in on this as well because Sachin mentioned something very pertinent about that whole ecosystem, going to the colleges. We'd also spoken about going to schools with this. With your daily interactions with students, I know it's a very cliche thing to say in tech to be curious, stay hungry. I mean, they're great things, but they have to be really expounded upon. How curious are students now, given the practical implications of this is a long-term thing? How much do I have to pursue my passion to start making money in this space? Are children actually, are students being sort of distracted by some of the big pay packages coming in from the AI side or from big tech really trying to innovate? What are students telling us about the quantum revolution?
Yeah, so I mean, I can give you one example about students from my group itself. So out of the 9 students that have graduated PhDs, 4 of them have gone into setting up startups now. The last 4 of them have gone into setting up a startup, at least couple of startups. So there is a lot of interest amongst youngsters to not pursue traditional jobs, but to pursue this, enter into this startup ecosystem. And they are all smart, they have great ideas and everything. But as Venkat pointed out, since there is a lot of push from the government and also a lot of interest from the investors, I think these students are really motivated into setting up their own small companies and come up with innovative ideas to put things for practical applications. So that's one side of the thing. And on the other side, the interest among youngsters, even younger generation students like school students and high school students, etc., they're all kind of very fascinated by this ideas about quantum computing, quantum technologies, quantum sensors and things like that. So recently, in many of these institutes where Science Day is celebrated, right, on 27th February, National Science Day is celebrated. So in most of these events, there was at least couple of sessions on quantum technology. And students were very interactive in this session, at least in the one which happened at IISER Pune. So it shows that there is this awareness about quantum technologies and quantum computing is picking up really well, I would say.
You're right, Professor. And honestly, hats off to the team here at Convergence, the Ruven team, for actually having this topic here. Because I attend a tech conference every week. I'm on stage like this. It's maybe 1% that would be talking about this. It's been an education for me, and I'm glad that we've been able to share some of these insights. We're going to be wrapping up soon. Ashwin, I'm coming over to your side finally, yet again.
Yeah, waiting for it.
But tell me something, Ashwin. We spoke about scaling a startup. Now, you dabble in a bunch of things in emerging tech. Some waves have come, some winds of change have blown the other way. It has a Web3 reference there somewhere deep down inside. But tell me, AI seems to be the buzzword. We see the inflated salaries, the valuations coming in with AI, and then you get a reality check from DeepSeek and China telling you, you can do this at a fraction of the cost, a sixth of the cost. do you really feel the need to keep innovating as a startup in this space? And now quantum will be your mainstay? It will be your permanent focus area in the years to come?
So that's a really good question. I mean, the money currently would be in AI itself. Let's say, because the whole world is buzzing with AI right now. Everyone has AI in their mind and they're ready to pay for it, right? Quantum has not reached that stage, but it would soon be reaching that stage. Once we see realistic acceleration through quantum, or in the cryptography area, where let's say we say that the information that we have right now would eventually become will not remain secure for a long time. There are legacy systems, older systems which are already using those encryption protocols, which can be broken by like quantum computers at this moment as well, right? So the idea is that yes, for now the focus is on AI, making the most of AI, but quantum is obviously there. It's just like if you're in a race, right? There is AI, and then behind AI is quantum, right? It's catching up soon, and it might cross AI once it becomes powerful enough, right? So we have an eye on quantum. We are giving it all the motivation. We just wanted to cross the line before the other technologies. I mean, it's not like a literal analogy, but I'm saying quantum has all the potential to revolutionize all technologies currently, let's say IoT, even blockchain, or AI for the matter, right? And there already are, like, one of the ideas is quantum powered AI. Another idea is AI powered quantum, right? And then there is quantum AI based security. There is something like post quantum cryptography, which ensures that we are secure with what we have at this moment. So all of these technologies already exist. We just need to know how far we want to. We just need to hold on to them for the time being, and I think that's the way to go for now.
Okay, so just building on this as the way forward. I'm not sure. Do we have time for questions? Okay, we'll take up on this just after our session, and I promise to do a small little coffee pe charcha after this. But very quickly, because we are looking forward and we have a couple of minutes just to wrap up, and this time we'll start with you from the other end of the panel. Your key takeaway for compute would be in 10 seconds. What would that one takeaway be if you have to make that elevator pitch to the audience that quantum is the way forward? What would that one proposition be on your end?
Okay, so
10 seconds.
All right. So the brain functions, we assume, classically, but I think there is some quantum element there. So if you want to look at a sentient AI in future, I think quantum is the way to go.
Well done. That's an elevator pitch. Professor, can we come to you for this one?
Yeah, I think everything works on the basis of quantum mechanics, and quantum computers also have to work on the basis of quantum mechanics. So I think once we have computers that work on the principles of quantum mechanics, which are useful, then it's going to be just going to revolutionize everything.
All right, Venkat.
So to me, I think we have a huge opportunity as a nation in front of us. There are now 34 countries with national quantum missions. Why? Because whoever takes the lead has economic dominance for several decades. And we have the talent, we have the know-how today, we have the young kids who are great at programming and maths. So this is our chance, this is our time, we got to go and grab it. We got to do it.
Awesome. Sachin.
See, 30 years back when we got the exposure to PCs, we said that, okay, if we don't learn that, we will be left behind. But we started learning after we saw PCs working. Just 2 years back, we saw GenAI, we said that if we don't learn, we will be left behind. But quantum is giving us an opportunity. Everyone is saying that, okay, in 3 years, we'll be there. So right is the time that we should start learning. So you have so many jargons, start searching and start learning on that.
And last but not the least, no pressure, but this is going to be the biggest takeaway for us since it's the last thing we hear.
So two things. One is talent. Retrain yourself, train your children, train everybody around, teach everybody, even one term, more than sufficient. Two, the impact is going to be very high on various aspects. Natural disasters, climate change is one very big area. You will see it coming around. Cyber security, defense applications, multiple of them. And the reason it's going to happen is because the AI models are becoming unsustainable altogether to build anymore, which Venkat had touched at the very beginning. That's the reason quantum computing is going to hit us, and it's going to hit us very hard.
What an absolutely stellar panel. I'm honored that I got a chance to do this. I've been taking my AI notes as we speak, and I'll break it down. Guys, an absolute pleasure. Like I said at the start of this particular session, quantum computing, the jet fuel to power AI's growth, is what we were supposed to talk about. But I really think it's quantum computing that will change life as we know it, for me and for you and all of us here. A huge round of applause for this stellar panel, and thank you for being a lovely audience.
Check. Absolutely. If I was to use some adjectives like it was very promising, very illuminating, I think it'll stay as an understatement. It was a stunning discussion. Can we have a huge round of applause for all our panelists, essentially the moderator who brought so much spark into the discussion, a huge round of energy that can flow into the hall. Thank you so much. On behalf of Exhibition India, we'd like to present small mementos to all our panelists. May I request Aayush to kindly present the mementos to the speakers of the session. We thank Mr. Atul Tripathi. Thank you so much, sir, for bringing such brilliant idea, assuring words from you, bringing out the talent present inherently in India. Thank you. We are taking that with us today. A big thank you to Mr. Tripathi. And a big thank you to Mr. Sachin. Thank you so much, Mr. Sachin, for sharing your ideas with us. He was pressing on to the importance of how we need to create the ecosystem. Thank you so much once again. Ladies and gentlemen, let's hear it for Mr. Venkat. Thank you so much. Such promising ideas, such promising and revolutionary propositions from Mr. Venkat. Thank you so much. It was a delight to hear you. Thank you so much, Dr. Umakant. Thank you so much, sir, for bringing in the academia and the student perspective forward. Thank you once again. And a heartfelt gratitude to Mr. Ashwin. Thank you so much, Mr. Ashwin, to bring in the yet another dimension of the quantum landscape. Thank you once again. And may I request Mr. Dhruv Bell to kindly join us onto the stage and present a memento to the moderator of the session for wonderfully conducting and concluding the session, Mr. Aayush Ailawadi. Let's hear it for him. Ladies and gentlemen, a huge round of applause for the panelists and the moderator of the session.